Здравствуйте, дорогие друзья, слушатели и студенты. И мы с вами опять продолжаем наш урок, цикл уроков, только маленькими экспериментами. Дорогие студенты и слушатели, теперь мы будем продолжать наши уроки именно по предмету автоматизации технологических процессов и основам автоматики. Но мы будем преподавать именно не на русском языке, как было традиционно, а будем преподавать на английском языке, потому что следующие программы являются программами европейского стандарта, и их синтаксис связан только с 3 языками, которые пользуются. На данный момент сертификаты имеются только на 3 языка. Это английский, немецкий и французский. И учитывая это, мы хотим сделать маленький эксперимент и будем делать уроки на английском языке. Если вы позволите, я начну. Good morning, dear students. I'm again so happy to see you, and we'll continue our lessons in basis of automation and technology process. And today's theme is Programmable Logic Controller, PLC, and applications of relay in electropneumatics. Today we'll talk about the logic controllers in a basis of Siemens, and we will talk about making relay and contact relay systems for technology process in example. Today we will understand the general information about controllers, logic controllers, what is that and why we use them, how they are effective in technology process, and why they push out the classic relay control shields and take a main point of controlling process in controllers, in technology process, I'm sorry. And the second one, we will talk about the logic symbols in Step 7 control software. It's a special software for programming the controllers of STEP system and system of International Electrostometric Committee. And the third one, we'll make a little example in programming of logic control system with the using of PLC. We'll take a task of controlling technology process, and we'll step by step making algorithm of work for controller and make a software to control it, and we'll download and see the result, how it will be possible to move and control. Okay, let's start. First of all, we need to understand what is the controller, why they call it programmable logic controller or programmable controller, why they call it. Controller is industrial digital computer which has been ruggedized and adapted for controlling of manufacturing process, such as assembly lines, robotic device, or any activity that required high reliability, easy of programming, and the fault diagnosis. This is all is based of controlling. In these parameters, it's the best set to use in technology process. In the right side, you can see the one of example controllers of controlling technology process. It's a Siemens, and today we'll make an example in this controller in software, which specification for this controller. Okay, first, why we call controller like a computer for manufacturer, and why they adapted to technology process. First of all, logic systems and logic operation which we use, it's like a connection, dissection, and move processes, and work with numerical systems and digital systems, making self-making decision systems. This all could be made all in computers. In IDEA, we take a computer, which we use, like your personal computer, resize it, take off the equipments like a keyboard, system blocks, and other tools which you use, like a printer, and so on. And make it in a maximal little size with the algorithms and counts. We just take algorithms and counts and incoming and outgoing signals. This is all is controller, nothing else. And as I told you before, controller push out the classic controller shields of relay. Why they push out the relay system? First of all, they have a little size, as you see. In right side, you have a classic shield of control in the basis of time relay and shift relay and programmable just relay, simple relay. In the programming controllers, most important side is that you can change in a couple seconds the functions of controlling and making system. But in a classic shield, you need a change. As I told you before, to making new project or new plan of controlling technology process, you need to take off the shield. You must make your own, again, make a new system of control, set it, and test the process, technology process, and it's take a lot of time. But in programming, in controllers, you just download the program by your own computer with Ethernet or other type of module. You will connect and just download, and then process is start. In a short reason why now manufacturers and manufacturers don't use the relay shield of control is a time of work. Unfortunately, classic relays work on magnetic contact, and no one can expect that when they come out of work. And it's very dangerous in a big manufacturers like electrostations or in chemical factory. It's very accidental situation and dangerous. So, in a reason of this, technology process start to use controllers. First, let's introduce controller. Here in the middle, you can see the controller, and a right side, the blue lines. This blue lines is I/O, call it I/O. If we resize it, it's input and outputs. I, it's input. O, it's output. Input is signals which come to controller from sensors, from acting machines, and other device which can give the analogy or digital signal. And then, according to the algorithm, a controller come out the signal to do next process. It's called output, or O. In the left side, we can see the special panel for users, for a person which will use. It could be the ports of connection, and buttons for connection, and a place to make a memory card, connection memory card. Is all you can see in the left side. In some situations, we have a lot of technology process, but all of them we can just consistent in one set, in one controller. To do this, we just take a lot parts of little piece connection controllers and make a single. Like I showed in this presentation, you just make a little complex, and then you can use a more device to control. Here a picture how you can connect the next bits to make a pins, new pins, and make action to take a result, or just commit the result, connection, just analyzing fault results, diagnosis. You can take more and more if you just connect a new one controller and make a single system. And the next advantage of controller is that you can make a remote system. You can adapt a technology process to your controller, and you make an autonomous place to connect, as I showed in this presentation. In the right side, you can see it. You just send the information of connection, and other device will take it and work. You continue work. You don't need to go there, switch off, or looking how it's run, how it's happened. And the one example of how next controller connected to other devices, and you just can stay in a bottom side of all the process and see how it happened in the top of the process. And controllers consist in not connection and connection relays, and they have a logic of bool logic, and all of them is downloaded to controller, and they work on basis of this. And in result of this combination, controllers can make PID regulation process, and the SPC is a process of changing, taking a date, accounting, and take a full date of process, technology process. How we can make an automation system or just software to controller? If it's computer, maybe we can some device to connect him and make a special program. Useful, easy site, and I think only one now the type of connection to controller is making just own PC computer or laptop, make a connection module and connect it to computer. And then you will make your own program and just download it for controller. And then controller, according to your logic, will change signal circulation inside of controller. And then it will give output signal to the other acting machines to making algorithm of technology process which you need. According of your terms, according in your logic and rules of control. Today we'll use the special program software. If we have a laptop, we must have any program with a special syntaxes of program. And today we'll talk about step 7. It's a special device. And to start work in step 7, we'll do together, step by step, for step 7. Okay, first of all, we need a manager to take controller. When you just connect your laptop or computer to controller, computer must see this device. And when you connect your computer, you must just open the software, step 7, and make diagnosis to find the device, like shown in the right side of slide. The semantic manager, all the data and automation projects, all the tools which you need and edit to make it standards of automation, just making a management to your program is doing by this manager, which I show in the right side. Okay, step 7. What is the step 7? Step 7 have engineering tools and at the same time have a runtime software. And engineering tools, it consists of 3 parts. First is high-level language. It means that language in international range, which useful in all world. They don't have any individual rules. It means that it's very useful. And the second one is graphic language. Some people have a difficult in making text programs like in C++ or Python. But in step 7 from semantic, they have a CFC, international language, and it's have a connect to CFC, and you can make a graphic language of programmistic and use it and download for your controller. And the last one and most important is supplementary software. It can supply to all the sets, all the bases which have in the library. You can download new library and just work with the new devices. They have 6 library types. You can download it and use. It means you don't need to take special programs to other sets and device. Only step 7, it's enough to make technology process and of course controller. Let's talk about the runtime software. In runtime software, controllers, we have a PID controllers and fuzzy controllers to make a fuzzy logic. And tools for linking with the Windows, and at the same time, race-time operation systems. They're different a little bit, and today we will use the tools for linking with the Windows, with M7 DDE. Today we will use the block program in language of LD, ladder diagram. And let's talk about the advantages of this program, why we choose the step 7 and why we choose a ladder diagram to programmatic language of controller. First of all, extensive programs are easier to understand. If you are an engineer, you will understand all principal schemes or electrostomatic schemes, and it's very useful. You don't need to be a professional programmer, you just need a logic and ability, knowledge about making electrostomatic schemes. If you're an engineer, I think it's no problem. And second advantage is individual program sections can be standardized. All the program, you just make this old program as a graphics, but in the end of downloading process, the program take for one standard, and it will be very easy to work. Third one is a program organized in simplified. As you know, all the grade is simple, and this program is simple. And fourth one, it's easier to make modification to the program. Of course, when you download to controller in the base of step 7, if you don't have any same computer to program, you just connection again to controller and can take out the program, change it, and again download. You don't need any special computer for programming. All computers with the step 7 can take out the program which have in controller. Fifth, easier to make debugging, simple science, you can test separate sections. When you make a program, you can make a simulation of circulation in end before the starting technology process. And I think it's very important because some accidents maybe happen if you don't give attention. Sometimes make some problems in program. And here you can test. And the last one is commissioning your system is made much easier. Step 7 has his own certification, and all the program which you do is just useful, and it's recommended to production. You don't need a special beta programmist and working in the manufacturers. If you can work with step 7, it's enough. Okay, here are block types of explanation in program for controllers. All blocks, as you understand, here we work with the 4 types of language, and the brief describes functions you can see in the middle side, and also what they connect and how they link it, and you can work it with them. Okay, step 7 is some software for development of automation process. As you can see on the right side here, we have an interface of program. Here in the middle side you can see your controller which you download. In the left side you can see the block stream. Here we have a CFC controlling type of language. And you can see the whole process. In the left side you can see all the folders which you have and folders which you make. And you can take all information from these folders and download to middle side, work side, and make your program. And then download to your controller. If you have 2 or more than controllers, it's easy because in the right side, as you see, you can switch to controller by one computer. It means in one laptop you can connect 2 or more controllers, and you can switch to other controllers by just clicking with your mouse. In the right side, in the client right side, you have a library of using sets and devices which you need. When you take information from this library, your program software adapt to this device and give you a recommendation to program. And it's very easy to use. Let's see closer. As I told you, folders which you make, and when you start the programming, here you have in the left side second folder, second one is programming source. Here stay your main program. When you open the main program, you will have this window which you see in the middle side with the blocks. Here a yellow one identification, and right side the situation or controller which you take. And to take this controller, you will use a library in the right side. When you choose a controller from the library, according to his name, they open this controller automatically. You don't need to put it or move it. It will be very easy. In the downside, in the bottom, it's a situation of programming. Either go good or worse. And if you have any faults, here will be red. And when you complete, here will be linked like a green one. Okay. Here we have again advantage, which we talk about, and following how we need to work. An example. Let's start. We talk about this very a lot. Let's work and do it. Today, task making special tank with the 2 pumps, pump number 1 and pump number 2. In a tank, we have a mixer to mixing 2 types of liquids. As you understand, we have 2 different types of liquids. They come to this tank and the mixing by mixer. And we have two sensors. And these two sensors will talk about the low level of liquid and a high level of liquid. When we start to work with the two pumps, pump number 1 and pump number 2, coming to the tank, the liquid's coming to the tank, two sensors of high level and a low level must give a signal according to the valve, according to the liquid flow. If we have a low level, pumps will switch off the work. If we have a high level, mixer will start to work, and he will rotate and mixing 7 seconds, and then switch off. After this, when the mixer is stopped to work, we will have a delay to 2 seconds, and then valve open and give to user. Today we'll try to make his algorithm, program, and a simulation. Okay, first of all, algorithm, how it will work. Let's imagine again relay and the technology process. Here we have a low level. Low level using for connect and switch off or switch on, it's switcher. When we detect it in low level, that is a level of liquid is low, it gives the signal to the pumps to switch off. When we have a high level, sensor will give the signal to controller to the work to pumps. And when it's come down, connect is switch off. It means the technology process is over, and mixer must stop to work. And valve stop, all the process will stop. Okay, let's start. How we can do that? First, we will open our software and call him a mixer, and use the data to place where will stay our program. To then take out to your, I don't know, any device to remove for your controller. Too easy find. Here the first interface in semantic, and as I told you, in the right side you have a library. We will use here semantic HIM station. When we open this library, we will choose the name of our controller, type, model of controller. It is a semantic 300. And here we will have a special pockets of controller, elements of controller. You will choose that which you need. In our situation, we need a pack 300. When you open the pack of 300, software will ask which models you will use. And here, the outputs, you will put the outputs for which you will use these models. Easy. Models, library of models, names of models which you use, and linking for outputs, these models. And then, here I show the some of them, how you can move. Here we choose some models and put this table in the outside. As you put the first output, linking the similar. In the first table it will stay. When you make all models which you need, we will go to programming. Here are all models which we will use today. And when you complete the match all models which you need, here you will give the address of input and output. I want to say that in output address, semantic use a special special signal. It's Q, not O. For output, they use Q. For input, they use I. Okay. After that, we make models, download them to software. We will make a linking to the run, to stop, to all the pins which have a controller, making pinning. After that, we will open the software site to programming. How it will do? Here we have a network. To network we will use blocks which we need, and the start. Okay. In algorithm I told you that we have two level sensors. They will be input and a stop. It will be input the same because the signals which coming to controller is the main thing which make a decision of controller. And as I told you, mixer, pump, and pump, second pump, valve, all of them is acting machine. And they are a result of signal of controller. So they will be output. We will make a special, for ourselves, inputs, name, numbers. And then we will remove this information which you make in this algorithm. Remember, 01, 00, 02. They will name it here in address. In the middle side address, and we'll give the type of signal. In this time, we use the two sensors, digital signals, so it will be bool. Then we will use the level. How it happen? Here in the left side, I give you in technology process. In the right side, in program, how it will be. First, we put the level sensor incoming connection, and then blocks to start and to reset, set and reset. This block is for setting and resetting. When the set S have a signal, then the process is start. When R have a signal, it's will restart, the stopping process. It means when the sensor have a signal, it giving to computer, to controller, and controller choose switch off pump 1 and pump 2. When signal is over in the sensor, it means that signal is out and the controller make a decision to switch on pumps. Switch off and switch on according to the level sensor. Here we can see in the software how it's looking for. And the next, with the mixer, how it's possible. Here, as I told you, if you can remember, a mixer will work 7 seconds. So it's have a start and set and reset and time. So it will be aspects box with the two types of set reset with the time value, and you just put the 7, and for output give the mixer. In a result, after 7 seconds, it's start to work. Till this process, this valve will be off. And then here a little model, the whole box where it's work. First, we have a high and low level inputs, high and low level inputs, and a stop, push button of stop. They come to set reset block number O, MO, and this command going to pump number 1 and pump number 2. When the signal comes from these connections, pump number 1 will start to work. When low level signal sensor gives a signal. And a mixer. In a high level, when a high level sensor gives a signal, pumps will stop. In the same time, when the pumps number 1 and 2 is stop to work, automatically start the mixer working in 7 seconds. And it's going to valve. It means when the high sensor work and mixer start the mixing and stop, it's mean that valve in the downside will open and liquid go to user. When low level sensor is activated, valve close and liquid just stop to come out to user. And here a drawing of system, how it looks like, and this whole process with the time period, how it will happen in modulation for mixer. Here the all sections to the mixer and sensor work. And in the end of my lesson, I want to give my thanks and acknowledgement to administration of Tashkent Institute of Irrigation and Agriculture Mechanization Engineers, and for administration of Academic License International House, and for UZREPORT TV for translation this good, I think, awesome lesson. Thank you very much. You are the best listeners. I hope we will meet with you again in this subject. Goodbye.